I found a cool Java game dev library called libGDX. Apparently, Slay the Spire was made with it, as well as a couple other cool games. I'm gonna make a little space simulator to try it out. To install the library you need a JDK version 8 to 17, since apparently Gradle doesn't support version 18 yet. Okay, let's get that. Now that that's done, we can create our project. The library has a project setup tool, so use that to create my environment. Now here I selected the wrong options, since I really only needed the desktop target. Later on I deleted the needed folders. After installing the library we can start drawing some simple shapes. The library's website links to some cool tutorials. One of them shows us how to draw some circles. So instead I decided to draw a triangle, for no good reason at all. Here's what we get. The library has a shape renderer, which is pretty handy. Now we can make a triangle class and use it to make the triangle move. And at this point I decided to just go and code some of the tutorials behind the scenes and read some documentation before starting the actual project. In case you're wondering, here's what I got after finishing the tutorials. First, I have a breakout clone, which has to be some of the worst code I've ever written. And second, I have a game about collecting water drops in a bucket with some sprites and sounds. I also read some wiki pages about memory management, asset management and viewports. At this point it should be okay to start coding the space simulator. For this video I'll make a solar system sim, which we can later extend. The initial implementation will be very naive. I've also chosen to keep it two-dimensional for now. I'm going to create a celestial body class, which will store the position of the body, its radius, its mass and its current velocity. The body is going to be represented by a circle. The first equation we need for the simulation is called Newton's law of universal gravitation. Here, the gravitational force applied to the body by another body is equal to the first body's mass times the second body's mass times the gravitational constant, divided by the squared distance between the two bodies. Now we'll actually need the force vector instead of just the force for the universal gravitation, since we can have multiple directions of gravitational pull. We just need to multiply the previous equation by the directional vector. The second equation we need is Newton's second law of motion, where the force is equal to the mass of a body times its acceleration. Using our two equations we can calculate the gravitational acceleration. Here's how these equations are represented in the celestial body class. All we need to do to calculate how a body will move each frame is to calculate its gravitational acceleration caused by every other body in the system. I'll store the bodies in a list and I'll loop over them every single frame and compute the corresponding acceleration. I realize that this is quite inefficient, but I'll keep it this way for the sake of simplicity. Then the acceleration can be used to get the new position of the body, and with this let's see what things look like with two bodies. Okay, now let's try it with a dozen bodies. Now let's add some interaction. It would be cool to be able to add new bodies in real time. Remember the phone game called 8-Ball Pool? I thought I'd add a similar mechanic for shooting planets into the system. By clicking the left mouse button, the player selects the initial position of the new planet, and then by dragging they can shoot the planet into the system. The further the cursor is from the initial position, the faster the initial velocity of the new planet will be. The initial implementation just draws a line between the initial and the current position of the mouse when the left mouse button is clicked. The next step is to actually add a body when the mouse button is released. Next is the initial velocity based on the mouse position. It would be cool if these celestial bodies had colors, so I'm going to add that to the code. For now let's just keep the colors random, aside from the sun at the center of the screen, which will just make yellow. And with this we have a very basic initial implementation of a solar system simulator. Since we have the gravitational forces figured out already, making the sim more interactive to make it more fun should be pretty easy. I'll leave that for a future video. Thanks for watching and see you next time.